15. Light. You might have seen a beam of sunlight when it enters a room through a narrow opening or a hole. You may have also seen beams of light from the headlamps of scooters, cars, and engines of trains. Figure A. Similarly, a beam of light can be seen from a torch. Sum up. A rail engine. B. Lighthouse. Figure beams of light. You may have seen a beam of searchlight from a lighthouse or from an airport tower. Figure B. What do these experiences suggest? A. B. Figure looking at a candle through a straight and a bent pipe. (15.1) Light travels along a straight line. Bojo recalls an activity they performed in class 6. In that activity, he looked. Figure reflection of objects in water. At a lighted candle, first through a straight pipe and then through a bent pipe. Figure why was Bojo not able to see the candle flame through a bent pipe? This activity showed that light travels along straight lines. How can we change the path of light? Do you know what happens when light falls on a polished or a shiny surface? 15.2 Reflection of light. One way to change the direction of light is to let it fall on a shiny surface. For example, a shining stainless steel plate or a shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of light. Have you ever seen the reflection of trees or building in water? Figure. Any polished or a shiny surface can act as a mirror. What happens when light falls on a mirror? You have learned in class 6 that a mirror changes the direction of light that falls on it. This change of direction by a mirror is called reflection of light. Can you recall the activity in which you got the light of a torch reflected from a mirror? Let us perform a similar activity. Activity 15.1. Do this. Take a torch, cover its glass with a chart paper which has 3 narrow slits as shown in figure. Spread a sheet of. Paheli remembers the story of the lion and the rabbit from the Panchatantra, in which the rabbit fooled the lion by showing him his reflection in water. Figure. Figure reflection of the lion in water. Figure reflection of light from a mirror. Chart paper on a smooth wooden board. Fix a plain mirror strip vertically on the chart paper. Figure. Now direct the beam of light on the mirror from the torch with slits. Place the torch in such a way that its light is seen along the chart paper on the board. Now adjust its position so that the light from the torch strikes the plane mirror at an angle. Figure. Does the mirror change the direction of light that falls on it? Now move the torch slightly to either side. Do you find any change in the direction of reflected light? Paheli wants to know what makes things visible to us. Bojo thinks that objects are visible only when light reflected from them reaches our eyes. Do you agree with him? Look into the mirror along the direction of the reflected light. Do you see the slits in the mirror? This is the image of the slits. This activity shows how light gets reflected from a plane mirror. Let us play around with the images formed in mirror and know a little more about them. Activity 15.2. Do this. Caution. Handle the lighted candle with care. It is better if this activity is performed in the presence of a teacher or an elder person. Place a lighted candle in front of a plane mirror. Try to see the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror figure. The candle itself is the object. Now move the candle to different position in front of the mirror. Observe the image in each case. Figure. Image of a candle in a plane mirror. Bojo noted in his notebook, "Is it not surprising that my image is of the same size as me whether the mirror is small or large?" Was the image upright in each case? Did the flame appear on top of the candle as in the object? Such an image is called erect. An image formed by a plane mirror is erect and of the same size as the object. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on the screen. Can you get the image on the screen? Now place the screen in front of the mirror. Can you get the image on the screen now? You will find that the image of the candle cannot be obtained on the screen in either case. What about the distance of the image from mirror? Let us perform another activity. Activity 15.3. Do this. Take a chessboard. If a chessboard is not available, draw on a chart paper 64 8 into 8 squares of equal size. Draw a thick line in the middle of the paper. Fix a plane mirror vertically on this line. Place any small objects such as a pencil, sharpener at the boundary of the third square counting from the mirror figure. Note the position of the image. Now shift the object to the boundary of the fourth square. Again note the position of the image. Did you find any relation between the distance of the image from the mirror and that of the object in front of it? Figure. Locating image in a plane mirror. Paheli made a note in her notebook. In a plane mirror, the image is formed behind the mirror. It is erect, of the same size, and is at the same distance from the mirror as the object is in front of it. You will find that the image is at the same distance behind the mirror as the object is in front of it. Now verify this by placing the object anywhere on the chart paper. 15.3. Right or left? When you see your image in a plane mirror, is it exactly like you? Have you ever noticed that there is one interesting difference between you and your image in a mirror? Let us find out. Activity 15.4. Do this. Stand in front of a plane mirror and look at your image. Raise your left hand. Which hands does your image raise? Figure. Now touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror the right appears left and the left appears right. Note that only sides are interchanged. The image does not appear upside down. Now write down your name on a piece of paper and hold it in front of a plane. Figure. Left hand appears on the right side in the image. Figure an ambulance. Mirror. How does it appear in the mirror? Bojo saw an ambulance on the road. He was surprised to see that the word ambulance in front was written in a strange manner. Can you now understand why the word ambulance is written as in figure? When the driver of a vehicle ahead of an ambulance looks in her or his rear view mirror, she or he can read ambulance written on it and give way to it. It is the duty of every one of us to allow an ambulance to pass without blocking its way. You might have observed that in the side mirror of a scooter or a car, the images of all the objects appear smaller than the objects themselves. Have you ever wondered why is it so? 15.4 Playing with Spherical Mirror. Paheli and Bojo were waiting for their dinner. Bojo lifted a stainless steel plate and saw his image in it. Oh, this plate acts as a plane mirror. My image is erect and is of the same size. Paheli saw her image using the back of a steel spoon. Bojo, look here. I can also see my erect image, though it is smaller in size. This spoon also acts as a mirror of some kind, said Paheli. You can also use a spoon or any curved shining surface to see your image. Activity 15.5 Take a stainless steel spoon, bring the outer side of the spoon near your face and look into it. Do you see your image in it? Figure. Is this image different from what you see in a plane mirror? Is this image erect? Is the size of the image the same, smaller or larger? Smaller or larger? Figure. Image from the outer side of a spoon. Now look at your image using the inner side of the spoon. This time you may find that your image is erect and larger in size. If you increase the distance of the spoon from your face, you may see your image inverted. Figure. You can also compare the image of your pen or pencil instead of your face. Figure. Image from the inner side of a spoon. The curved shining surface of a spoon acts as a mirror. The most common example of a curved mirror is a spherical mirror. If the reflecting surface of a spherical mirror is concave, it is called a concave mirror. If the reflecting surface is convex, then it is a convex mirror. Figure A, B. Figure A concave, and B, a convex mirror. Why are concave and convex mirror called spherical mirrors? Take a rubber ball and cut a portion of it with a knife or a hacksaw blade. Figure A. Be careful, ask an elder person to help you in cutting the ball. The inner surface of the cut ball is called concave and the outer surface is called convex. Figure B. Concave surface A, convex surface B. Figure. A spherical mirror is a part of a sphere. The inner surface of a spoon acts like a concave mirror, while its outer surface acts like a convex mirror. We know that the image of an object formed by a plane mirror cannot be obtained on a screen. Let us investigate if it is also true for the image formed by a concave mirror. Activity 15.6. Do this. Caution. You will conduct activity in the sunlight. Be careful. Never look directly towards the sun or its image, as it may damage your eyes. You may look at that image of the sun when it is thrown on a screen or a wall. Figure. A concave mirror forms a real image of the sun. Take a concave mirror, hold it facing the sun, try to get the light reflected by the mirror on a sheet of paper, adjust the distance of the paper until you get a sharp bright spot on it. Figure: hold the mirror and the sheet of paper steady for a few minutes. Does the paper start burning? This bright spot is, in fact, the image of the sun. Notice that this image is formed on a screen. An image formed on a screen is called a real image. Recollect that in activity 15.2, the image formed by a plane mirror could not be obtained on a screen. Such an image is called a virtual image. Now let us try to obtain on the screen the image of a candle flame formed by a concave mirror. Activity 15.7. Do this. Fix a concave mirror on a stand, any arrangement to keep the mirror steady would you, and place it on a table. Figure: paste a piece of white paper on a cardboard sheet. Say about. Figure: real image formed by a concave mirror. 15 cm into 10 cm. This will act as a screen. Keep a lighted candle on the table at a distance of about 50 cm from the mirror. Try to obtain the image of the flame on the screen. For this, move the screen till a sharp image of the flame is obtained. Make sure that the screen does not. Figure: virtual image formed by a concave mirror. Obstruct the light from the candle falling on the mirror. Is this image real or virtual? Is it of the same size as the flame? Now move the candle towards the mirror and place it at different distances from it. In each case, try to obtain the image on the screen. Record your observation in table. Is it possible to obtain the image on the screen when the candle is too close to the mirror? Figure: we see that the image formed by a concave mirror can be smaller or larger in size than the object. The image may also be real or virtual. Concave mirrors are used for many purposes. You might have seen doctors using concave mirrors for examining eyes, ears, nose, and throat. Concave mirrors are also used by dentists to see an enlarged image of the teeth. Figure: the reflectors of torches, headlights of cars, and scooters are concave in shape. Figure: a dentist examining a patient. Bojo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and smaller in size. He wondered. Concave surface. Figure: reflector of a torch. If the ball is also a kind of spherical mirror, can you recognize the type of the mirror? Note that the reflecting surface of the bell is convex. Activity 15.8. Do this. Repeat activity now with a convex mirror in place of a concave mirror. Figure: record your observations in a table similar to table. Could you get a real image at any distance of the object from the convex? Figure: image formed by a convex mirror. Table: image formed by a concave mirror for object placed at different distance from it. Distance of the object from the mirror: smaller or larger than the object. Character of the image: inverted or erect, real or virtual. 50 cm, 40 cm, 30 cm, 20 cm, 10 cm, 5 cm. Do this and comment this. Figure: convex mirror as side view mirror. Mirror, did you get an image larger in size than the object? Can you now recognize the mirrors used as side mirrors in automobiles? These are convex mirrors. Convex mirrors can form images of objects spread over a large area. So these help the drivers to see the traffic behind them. Figure 15.5. Images formed by lenses. You might have seen a magnifying glass. It is used to read very small print. Figure. You might have also used it to observe the body parts of a cockroach or an arthur. The magnifying glass is actually a type of a lens. Lenses are widely used in spectacles, telescope, and microscope. Try to add a few more uses of lenses to this list. Get some lenses, touch and feel them. Can you find some difference just by touching? Those lenses which feel thicker in the middle than at the edges are convex lenses. Figure A. Those figure a magnifying glass which feel thinner in the middle than at the edges are concave lenses. Figure B. Notice that the lenses are transparent and light can pass through them. A, B. Figure a convex lens and B a concave lens. Let us play with lenses. Caution. It is dangerous to look through a lens at the sun or a bright light. You should also be careful not to focus on light with a concave lens on any part of your body. Activity 15.9. Take a convex lens or magnifying glass, put it in the path of sun rays, place a sheet of paper as shown. Figure. Adjust the distance between the lens and the paper till you get a bright spot on the paper. Hold the lens and the paper in this position for a few minutes. Does the paper begin to burn? Now replace the convex lens with a concave lens. Do you see a bright spot? Figure. Real image of the sun by a convex lens. On the paper this time too. Why are you not getting a bright spot this time? We have seen in the case of mirrors that for different position of the object, the nature and size of the image change. Is it true for lenses also? Let us find out. Activity 15.10. Do this. Take a convex lens and fix it on a stand as you did with the concave mirror. Place it on a table. Place a lighted candle at a distance of about 50 cm from the lens. Figure A. Try to obtain the image. A convex lens converges, bends inward, the light generally falling on it. Figure A. Therefore, it is called a converging lens. On the other hand, a concave lens diverges, bends outward. The light hand is called a diverging lens. Figure B. A, B of the candle on a paper screen placed on the other side of the lens. You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is it real or virtual? Now vary the distance of the candle from the lens. Figure B. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observation as you did in activity for the concave mirror. It means that we can see the image formed by a lens from the side opposite to that of the object. A, B. Figure. Image by a convex lens for object placed at different distance from it. Figure. Virtual image formed by the convex lens. Figure. Image formed by a concave lens. Did you get in any position of the object an image which was erect and magnified? Figure. Could this image be obtained on a screen? Is the image real or virtual? This is how a convex lens is used as a magnifying glass. In a similar fashion, study the images formed by a concave lens. You will find that the image formed by a concave lens is always virtual, rect, and smaller in size than the object. Figure 15.6. Sunlight, white or colored. Have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is low in the sky. The rainbow is figure a rainbow, seen as a large arc in the sky with many colors. Figure. How many colors are present in a rainbow? When observed carefully, there are 7 colors in a rainbow, though it may not be easy to distinguish all of them. These are red, orange, yellow, green, blue, indigo, and violet. Does this mean that the white light consists of 7 colors? Figure. A prism splits a beam of sunlight into 7 colors. Figure. A CD placed in sun. You might have seen that when you blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of a compact disc CD, you see many colors. Figure. On the basis of these experiences, we say that the sunlight is a mixture of different colors? Let us investigate. Activity 15.11. Do this. Take a glass prism, allow a narrow beam of sunlight through a small hole in the window of a dark room to fall on one face of the prism. Let the light coming out of the other face of the prism fall on. Bailey wants to tell you that you can see a rainbow only when your back is towards the sun. A white sheet of paper or on a white wall, what do you observe? Do you see colors similar to those in a rainbow? Figure. This shows that the sunlight consists of 7 colors. The sunlight is said to be white light. This means that the white light consists of 7 colors. Try to identify these colors and write their names in your notebook. Can we mix this color to get white light? Let us try. Activity 15.12. Do this. Take a circular cardboard disc of about 10 cm diameter. Divide this disc into 7 segments. Paint the 7 rainbow colors on these segments as shown in figure A. You can also paste colored papers on these segments. Make a small hole at the center of the disc. Fix the disc loosely on the tip of a refill of a ball pen. Ensure that the disc rotates freely. Figure A. Rotate the disc in the daylight when the disc is rotated first. The colors get mixed together and the disc appears to be whitish. Figure B. Such a disc is popularly known as Newton's disc. Figure A. A disc with 7 colors. B. It appears white on rotating. Bailey has a brilliant idea. She has prepared a small top with a small circular disc with 7 rainbow colors painted on it. Figure. When the top rotates, it appears nearly white. Figure. A top with 7 colors. Keywords. Concave lens, concave mirror, convex lens, convex mirror, erect image, magnified image, magnifying glass, prism, rainbow, real image, rear view mirror, side mirror, spherical mirror, virtual image. What you have learned. Light travels along straight lines. Any polished or a shining surface acts as a mirror. An image which can be obtained on a screen is called a real image. An image which cannot be obtained on a screen is called a virtual image. The image formed by a plane mirror is erect. It is virtual and is of the same size as the object. The image is at the same distance behind the mirror as the object is in front of it. In an image formed by a mirror, the left side of the object is seen on the right side in the image, and right side of the object appears to be on the left side in the image. A concave mirror can form a real and inverted image when the object is placed very close to the mirror. The image formed is virtual, erect, and magnified. Image formed by a convex mirror is erect, virtual, and smaller in size than the object. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image formed is virtual, erect, and magnified. When used to see objects magnified, the convex lens is called a magnifying glass. A concave lens always forms erect, virtual, and smaller image than the object. White light is composed of 7 colors. Exercises. Do this and comment this. Extended learning activities and project. Do this and comment this. Figure candle burning in water. Did you know the mirrors can be used as weapons? Archimedes, a Greek scientist, is said to have done just that more than 2000 years ago. When the Romans attacked Syracuse, a coastal city statue in Greece, Archimedes used mirrors arranged as shown in figure. The mirrors could be moved in any direction. They were positioned such that they reflected the sunlight on the Roman soldiers. The soldiers were dazzled by the sunlight. They did not know what was happening. They got confused and ran away. This was an example of triumph of ideas over military might. Figure Archimedes mirrors.